In this video, I want to walk you through the step-by-step procedure of how to solve problems using the conservation of energy method. Okay, so step one. Step one is to identify what is the system whose energy is conserved. So, what objects are you including in your system? What energy are you keeping track of? And also, what types of energy do you need to keep track of? So, for instance, I mentioned that there's a bunch of different kinds of potential energy. So which types of potential energy are you actually going to need to keep track of between the initial and final states, so that you make sure you know what you're working towards. Step two, you want to identify the initial and final states that you are comparing to each other, and ensure that the energy is the same in the initial and final states. I mentioned that energy is conserved, so how could, why wouldn't the energy be equal in the initial and final states? And the answer is energy might enter your system or leave your system. For instance, if you have two objects that are exchanging energy, the energy of each of the individual objects is not necessarily conserved, but the energy of the system of both objects combined is conserved. So make sure that your object is not dumping energy out somewhere else that's going to screw up your conservation of energy. We'll talk about how to deal with that case later on. So identify the initial and final states. Number three is sketch the initial and final states, including any information which is going to help you calculate your various forms of energy, depending on what they are. That might be a little bit different. Number four is something which I haven't really explained yet, but is something which will become important a little bit later on. Sometimes you need to choose a reference point for potential energy. And by reference point, I mean, what does potential energy equals zero mean for this problem? Again, that's something which I'm going to come back to later on. It won't make that much sense yet, but there are some cases where that's very important to do. Number five is to write an expression for the initial energy. And then number six, write an expression for the final energy. And then number seven, set the initial energy equal to the final energy. So you'll notice that this is very similar to the procedure for conservation of momentum, not surprisingly, because they're both making use of conservation laws. It's also pretty similar to the procedure for solving kinematic equation style problems, because in that case, you're also comparing an initial and final state. So we'll get some practice solving these problems shortly, but in this video, I just wanted to give you the basic procedure.